Hey everyone, welcome back to another lesson on neural notes. Today we're going to be talking about large language models, how they work. So, for this, I want you to imagine like you're sitting down to produce a new track. But which notes do you press? How do you start making the melody? You don't start, technically speaking, you don't start completely from scratch. You draw from your memory, from patterns, sounds, and chord progressions that you've heard and studied before. Your brain predicts which note or drum hit should come next based on your experience and all the songs that you've listened to. That's kind of how a large language model works. It has this and concept context and lots of background information fed through data to be able to kind of generate its own text. So let's break it down. Going to our DAW here, BandLab. Let's just say you add a single note, C. Okay, so now what could be a next note that I add? You'll probably guess something that fits, maybe an E or a G, because they sound good together in the key. Because all those three, C, E, G, form the simple C major chord. But see how you just didn't pick any random note? You would choose something that would make sense based on what came before it, based on your understanding of music theory. By the way, guys, if you don't know music theory, completely fine. Just follow along like you do. I promise you won't really need it to understand what I'm saying. But anyway, going back, that's exactly what an LLM does. It predicts the most likely next word based on the words before. And to kind of give you an example now in the English language, let's just say I'm typing up a sentence. The cat sat on the. The cat sat on the. You have this context, and now you want to predict the next word. Remember, LLMs generate word by word, kind of how like we go as producers note by note. Anyway, going back. So the cats sat on the. Would it make sense to say walk, any random word? No, that doesn't make sense. You would probably have some kind of noun, like a mat or a sofa. Just like that, it generates word by word and or in special terms, token by token, and based on the context and background. But now the question is, how does a model know what comes next? Well, just like people study lots and lots of music theory and songs to give them some intuition of notes, the model also wasn't born just knowing grammar. It learns by listening to different examples that are fed into it. So basically, an LLM is trained on billions of words and sentences that it picks up from patterns in a language, just like how musicians pick up common chord progression. The model doesn't necessarily understand the language like humans may comprehend, but it's a through pattern recognition, it's able to see what usually comes next. Alright, so now I want to take you on a very special part of large language models that you guys will probably be working on in your own projects and is really hot and applicable in today's AI world. And that is fine-tuning large language models. And to understand, let's again go to our doc. So let's just say I want to make a track, but I want to make a track in some specific genre. I want to make maybe an R&B, Latin, and house. So let's just go here what I've made, some simple beats in each of these genres. That was our R&B a little bit. Now I'll give you a Latin tune that I just made. And a house. Alright, so these are all three different genres made from pretty much the same instruments: bass, drums, some chords, and some melody, right? But we all felt really, really different vibes. And that's kind of what fine tuning is. It's using some base structure or model and kind of modifying it to fit one specific domain or um, use case. So, for example, if a base model is trained on everything from novels to Reddit threads, fine tuning it on, say, medical papers or Shakespearean poetry makes it better at generating text in those specific styles, just like how a producer would be able to fine tune their sound for these different genres. And to really see what I mean by these different genres, I want to focus in on the drums here. Let me single out the drums and just hear how these drums are slightly different from each other. The Latin now. You can hear the tom much more high pitched, lots of more hi hat, having lots more reverb, and same with the bass, lots of more reverb and volume with the bass, I'd say. And then house having a lot more offbeat kind of syncopated rhythms, as well as lots of reverb on the bass, but a um, very what you call it? Very tight and very in the pocket hi hat sound, and that's kind of the difference. But the one thing I want you to notice in all three is that you're taking some bass structure and kind of adapting it to some specific genre. And that's exactly what fine tuning is. And usually when you're working on your projects, we'll take some base model as in ChatGPT or Gemini, DeepSeek, and adapting it to your specific use case by feeding it in lots and lots of data within that domain that you work in. That way, it has that relevant context and can give more, better, and accurate answers for that. And that's the beauty and power of fine tuning your large language models. And that's how LLMs work, predicting word after word, just like we build music note after note. It's not magic, it's just pattern prediction on a very, very massive scale. And so I urge you that next time you listen to a song, think about how it follows very familiar patterns while still feeling fresh, just like how AI generates text that feels natural. Essentially, it's building on these different patterns. And so, if you found this interesting, hit that like button and subscribe so we can reach even more people. And we're going to be coming with more music and AI breakdowns coming soon. Thank you.